Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at polynomial division. We will divide this cubic polynomial by this linear polynomial. So essentially we want this. We want to be able to take x plus 2, the thing by which we're dividing, multiply it by some other polynomial, and end up getting our cubic polynomial. But like all divisions, this might not go evenly into this. There may be a remainder, so we have to leave room for that. So I'll call this remainder R. Now, when you're doing polynomial division, this remainder is always at least 1 degree lower than the polynomial by which you're dividing. So this is a degree 1 linear polynomial, so this must be degree 0. This must be a constant. I may not be able to find a polynomial that I can multiply by x plus 2 to get this evenly, but I'll get really close and just have to add a constant. Now, if I want to multiply x plus 2 by something to get a cubic, this is going to have to be a quadratic. I need it to have an x squared term so I can end up with x cubed. I need to multiply x by x squared to get x cubed. So it's going to be a quadratic. It's going to be something times x squared plus something times x plus something. So polynomial division is going to allow us to construct this polynomial and basically find the coefficients that should go here. So let's set it up using long division notation. So as discussed before, our answer is going to be a quadratic. So it's going to be something times x squared plus something times x plus something. And we may have a remainder as well. So how we perform this division, we start with leading term, divide leading term. X cubed divided by x is just x squared, or 1x squared. We've figured out that a 1 must go here, so that when you multiply x by this 1x squared, you get x cubed. So when we get something up here, we have to multiply it by the polynomial by which we're dividing. So x squared times x plus 2. X squared times x, and x squared times positive 2. So the reason we do this is to compare what we have with what we want. See, if I went and expanded this, when I multiply the x and the x squared, I do get x cubed. That's great. But I'm not going to get 3x squared. I only get 2x squared. We have to make an allowance for that. So we're going to calculate the remainder, how far off we are. Well, x cubed minus x cubed is 0. 3x squared minus 2x squared is just 1x squared. Now, whenever you get a remainder, divide it by the leading term. X squared divided by x is just 1x. So we're going to put a 1 in this box as well. So we need to put a 1 here so that we can get the second term right, 3x squared. When we expand this, x times x, that will give us 1x squared, 2 times x squared, 2x squared, add them together. Now this term is correct. So we're going to keep repeating the process. So we've got the remainder. We're going to move this down now, and we're going to, again, compare what we have with what we want. Now, as I said, anytime you get something up here, you need to multiply it by the polynomial by which you are dividing. So x times x plus 2 gives us x squared plus 2x. So this is what we wanted to get. This is what we will get if we expand what we have so far. So we're going to calculate the remainder. X squared minus x squared is 0. Negative x minus 2x, that gives us negative 3x. When we have a remainder, divide it by the leading term. Negative 3x divided by x is negative 3. So we figured out a negative 3 needs to go in this last box. So that will ensure that these three terms are correct when we do this expansion. But what about the constant term? Well, let's double check that. We're going to bring down this one here. So when we get something up here, we multiply it by the polynomial by which we're dividing. So negative 3 by x is negative 3x. Negative 3 by 2 is negative 6. The remainder here, 1 subtract negative 6 is 7. That is our remainder for the whole thing. It means if I were to multiply out these, expand them using FOIL, I would get x cubed plus 3x squared minus x, but I would actually get negative 6 there. So I need to add a 7 to balance these equations. This last number you get is the remainder of the whole division. It can actually be useful to help you check if you're on the right track. So we're going to use the remainder theorem. So if I call this top cubic there f of x, the remainder theorem tells us that when you divide this by x plus 2, the remainder will be f of negative 2. It's always the negative of this, or the root of the polynomial by which you're dividing. So this just means substitute negative 2 into this expression here. So that is x cubed plus 3 times x squared, subtract x plus 1. And if I put that on the calculator, I get 7. That's what the remainder should be. That's the remainder I obtained, so I know I'm on the right track. All right, let's look at another example where we use polynomial division in order to factorize. So let's look at this example here. I want to solve this cubic equation. Now, I don't know if you've ever seen the cubic formula, but it's so long and complicated, nobody, including me, remembers it. I want to solve this equation here by factorization. Unfortunately, though, I can't use any of the factorization methods we've previously learned. There's no highest common factor amongst the terms. It's not the sum and difference of cubes, and we can't use grouping either. What we need to do is find one of the roots, one of the solutions to this equation, and then we're going to use polynomial long division to find the others. So we need to kind of guess a solution first, but luckily we have the rational root theorem, which means we don't have to just blindly guess numbers. I'm going to start by guessing integer factors of this number here. So we can guess a few of those, and it turns out 3 helps us. So f of 3, that means I substitute x for 3 here. That gives me 2 times x cubed minus 17 times x squared plus 48 times x minus 45. I chose 3 because it's a factor of 45. It turns out that that is a root. 3 is a value I can substitute to make this 0. So the factor theorem tells us that x minus 3 is a factor. So I am going to use polynomial long division. Now that I have a factor, I'm going to see how x minus 3 goes into the cubic. So I'll do this one quicker than on the previous slide. We always start by going leading term divide leading term. 2x cubed divide x is 2x squared. When we get something at the top, multiply it by this polynomial here. So 2x squared times x and 2x squared times negative 3. We subtract to find the remainder. This minus this is 0. Negative 17 subtract negative 6. Gives us negative 11x squared. When we get a remainder, it gets divided by the leading term. So negative 11x squared divided by x gives us this. So we bring down the next term, the positive 48x, but when we get something up here, we need to multiply it by this. So negative 11x times x, negative 11x times negative 3. We always subtract to find the remainder, so that's 15x. Whenever we get a remainder, divide it by the leading term, so we're left with 15. Now we're going to calculate the remainder of the whole thing. It should be 0 because we know that this is a factor. So we bring down the negative 45. So now we multiply 15 by this 15 by x and 15 by negative 3, and we see that the remainder overall is 0. So what we've actually found is that our original polynomial, the cubic fx, I can write it as x minus 3 multiplied by this quadratic up here. So we've reduced this cubic into factorizing a quadratic, which I know we know how to do. So do this. 2 times 15 is 30. We're going to split up the middle term using two numbers that multiply to 30 and add to negative 11. So that's negative 6x and negative 5x. We then factorize the first two separately and the last two separately. So now x minus 3 is the common factor. So I get x minus 3, leave that one alone. I get another x minus 3. And then in the last bracket, it's just what's left over, 2x minus 5. So we already knew that x equals 3 was a solution, but polynomial long division allowed us to find the other solution. If 2x minus 5 equals 0, then x is equal to 5 over 2. We have found all the solutions and are done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.